So this is the integration formulas it looks like. So this is the indefinite integrals. So what is the indefinite integrals in terms of we have from the trapezoidal rules basically. So this is how the illustration for the indefinite integrals. To do the integrations, we have the a to b, so it's the lower bound is a a, upper bound is a b. So when we do the integration, basically we will get something like the area below the curve, like this one. So when we do integration for this, basically we get the area below this curve here, and this is how the area we get this one. Based on this integration, we get this one. Because of the trapezoidal rules, we are using this kind of the idea to do the approximation, and we take this is the shape. It's just like the trapezoidal shape, like this one. So this is actually just a trapezoidal shape we do for the approximation. So because of that, we can use this kind of the idea to develop the formula like this. So where this is your h, the h, and then this is the fi plus 1. So basically it's just a height over here, and this one, and this is how the formula is come from the trapezoidal rules. And next, because of that, we can also divide the big numbers of the big trapezoidals shape. We can divide it into n numbers of the strips over here, like this one. We can divide it into even more smaller interval h here, and each of them I can just label like this one, x1, sorry, x0, x1, x2 until xn over here. So each of the increment just increase by the h, the step size, like let's say 0.1. So every x here will increase by 0.1, 0.1, 0.1, like that. So because of that, we want to get the, let's say we want to get the integration from a to b. So we just replace our the a here is just the x0, and then our b we just replace by the xn. So because of that we have the n numbers of strips. How we get this one actually? It's based on this fundamental theorems of the calculus. So it means that if let's say you have the c in the middle of the a and b, the point, just in between. So the integration for a to b you can split into two like this. So the value of this integration will be the same for this one, and this is why the reason we have this, because this is a x0 to xn, basically it's just from a to b here. So this one, so the integration basically we have the n number of strips, so that's why we can just divide our integration into the n numbers of like this. So meaning it's a 0 to 1, so this is the first integral, plus x1 to x2, the second integral is just for the second strips, and do the same thing until the end of the strips over here. And next, how we going to do for the formalizations to the formulas. So basically this is somehow like we take this is the first integrals will be the first trapezoidal rules we're using for each of the case here, 1, 2, 3 until the fn here. So meaning this is the f0 here, and this is the f1, and this is the first formula, and then this is the first formula for the second integrals, and this is another one for the last integrals. So next we just simplify this, you will get the generalized formulas like this one. So it's every here, every the integral, the formula here, this is the h over 2, h over 2, h over 2. So that's why I can just factorize, we have this. And you notice that the first and the last integrals, so basically we don't have nothings, so that's why it's the f0, fn. But you see this is f1, and this is we have the f1 in the second terms here, the second integrals formulas here. So that's why later there will be have 2 f1. The same thing for f2, f3 until the fn minus 1. So this is how I just make the formula of the generalization.